Imagine you wake up one morning, the sun is shining, the birds are singing. Everything feels completely normal, but deep beneath your feet, something profound has happened. The very heart of our world, the Earth's core, has stopped spinning. You wouldn't feel it at first. There would be no sudden jolt, no immediate sound to warn you of the change. It would be a silent, invisible catastrophe. A change so fundamental, it would set in motion a chain of events that would unravel our world piece by piece. The story of our planet is written in motion, and that motion has just ceased. This isn't a monster from a film. It isn't an alien invasion. It's a change in the fundamental physics of our home. The forces that have nurtured life for billions of years have been switched off. The silent hum of our planet's engine has gone quiet. This is a story about how fragile our existence truly is. A world with a fiery heart that beats in a rhythm of iron and nickel, spinning in the dark. What happens when that heartbeat stops? We are about to embark on a journey to the center of the Earth to understand the catastrophe that no one would survive. The day the core stopped would begin like any other. To understand what's happening, we need to look inside our planet. Think of the Earth not as a solid rock, but as a giant cosmic peach. On the outside, you have the skin. For the Earth, this is the crust. It's the thin, brittle layer we live on. It's where we build our cities and grow our food. It might seem vast to us, but compared to the rest of the planet, it's incredibly fragile and thin. Just like the skin of a peach, it can crack and break, which gives us earthquakes and volcanoes. Beneath the skin of the peach, you find the fleshy fruit. Inside the Earth, this is called the mantle. The mantle is a thick layer of hot, semi-solid rock that flows very, very slowly over millions of years. It's not quite liquid, but it's not solid either. Think of it like extremely thick honey or caramel. This slow, churning movement in the mantle is what drives the continents to drift across the planet's surface. Now, we get to the pit of the peach. At the center of the Earth, we have the core, but the core itself has two parts. First, there's the outer core. This is a vast ocean of liquid metal, mostly iron and nickel. It's incredibly hot, hotter than the surface of the sun. It's this liquid outer core that is constantly churning and spinning. It flows like water in a pot on the stove, driven by the planet's heat and rotation. And right at the very center, the heart of the peach pit, is the inner core. This is a solid ball of iron and nickel. Even though it's even hotter than the outer core, the immense pressure from all the layers above it is so great that it forces the metal to be solid. So why does a spinning ball of metal deep inside the Earth matter to us? It matters because this spinning core acts like a gigantic engine, a dynamo to be precise. As the liquid outer core, full of conductive iron, flows and swirls around the solid inner core, it generates powerful electrical currents. Think of it like the dynamo on a bicycle that powers a light. As the wheel spins, the dynamo generates electricity. The Earth's core does something very similar, but on a scale that is almost impossible to comprehend. This process is called the geodynamo. It's one of the most magnificent and important phenomena in the solar system. It is a beautiful feedback loop. The energy that drives this entire engine comes from the heat left over from the formation of our planet, some 4.5 billion years ago. This heat needs to escape, and it does so by causing the liquid outer core to churn, a process called convection. Hotter, less dense iron rises, cools, and then sinks, creating massive swirling currents. So, when we say the core has stopped spinning, what we really mean is that this dynamo has shut down. The engine has run out of fuel. The most important creation of our planet's spinning core is the magnetosphere. This is a vast, invisible shield of magnetic energy that surrounds the Earth. It extends tens of thousands of kilometers out into space. You can't see it. You can't touch it. But it is as essential to our survival as the air we breathe or the water we drink. The magnetosphere works by deflecting dangerous particles and radiation that stream from the sun. The sun is not just a gentle source of light and warmth. It constantly ejects a powerful stream of charged particles known as the solar wind. This solar wind travels at hundreds of kilometers per second. If it were to hit the Earth directly, it would be devastating. The shape of the magnetosphere is not a perfect sphere. On the side facing the sun, it is compressed by the force of the solar wind. Sometimes, some of the charged particles from the solar wind get trapped in the magnetosphere. They are funneled down towards the magnetic poles, where they collide with atoms in our atmosphere. This collision is what creates one of the most beautiful sights on Earth, the auroras. The northern and southern lights are a stunning visual reminder of the invisible battle being waged high above our heads. In our story, the core has stopped. The dynamo has ceased. The magnificent magnetic field it generated does not vanish instantly. It would take some time to fade away, perhaps a few thousand years, but its power would diminish rapidly. The first sign would be the auroras. They would become weaker, appearing at strange latitudes, flickering erratically before disappearing forever. The compasses we use for navigation would spin uselessly, their needles no longer tethered to a stable magnetic north. Migratory animals that use the magnetic field for navigation, like birds, sea turtles, and whales, would become hopelessly lost. Satellites in orbit would be the next to fail. Without the magnetic shield to protect their sensitive electronics from solar radiation, they would be fried one by one. As the magnetic field weakens to nothing, the solar wind, that relentless stream of charged particles from the sun, would begin to hit our upper atmosphere directly. The particles would slam into the molecules of air, one by one, and slowly but surely, they would begin to strip our atmosphere away. Our sky would change. The deep blue we know is the result of sunlight scattering off air molecules. As the atmosphere thins, the sky would become a paler, thinner blue, eventually fading to the black of space, even during the day. With the magnetic shield gone and the atmosphere thinning, the next assault would come from the sun's radiation. We're not just talking about the solar wind, but also about something far more dangerous: solar flares and coronal mass ejections. These are violent explosions on the sun's surface that release massive bursts of energy and radiation. On a normal day, our magnetosphere deflects the worst of these storms, but without our shield, we'd be completely exposed. The full raw power of the sun would be unleashed upon the surface of the Earth. A major solar flare hitting an unprotected Earth would be an extinction-level event. The radiation would be intense. It would be a flood of X-rays and high-energy protons, just bathing the entire planet. Any living thing on the sun-facing side of the planet would receive a lethal dose of radiation in minutes. It would be like standing next to a nuclear reactor during a meltdown. Plants would wither and die. Animals would perish. The oceans would offer some protection, but the radiation would sterilize the surface layers, killing off the plankton that form the base of the marine food web. Even for humans who might try to survive underground, the situation would be grim. The surface of the planet would become uninhabitable, and these storms would not be rare events. The sun goes through cycles of activity, and major flares happen regularly. We would be trapped on a planet that was being actively sterilized by its own star. The loss of our atmosphere would not only expose us to radiation, it would fundamentally change the climate and the air itself. The atmosphere acts like a blanket, trapping heat and keeping the planet's temperature stable. Without it, the temperature swings would be extreme. Daytime temperatures would soar to scorching levels under the direct, unfiltered sunlight. But as soon as the sun set, the heat would radiate away into space instantly. Nighttime temperatures would plummet to hundreds of degrees below freezing. This would create winds on a scale we can barely imagine. The extreme temperature difference between the day side and the night side of the planet would generate constant, planet-spanning storms. These would not be winds of air, but the thin, remaining wisps of our atmosphere moving at supersonic speeds. And what about the air itself? The solar wind would not just strip away the atmosphere's mass, it would break apart the molecules that compose it. Water vapor in the atmosphere would be split by the intense ultraviolet radiation into hydrogen and oxygen. The light hydrogen atoms would escape into space almost immediately. The oxygen, our precious oxygen, would not be safe either. It would react with other elements on the surface, becoming locked away in rocks, or it too would be slowly stripped away by the solar wind. The very air we need to live would vanish. In the end, Earth would become a silent, airless world. The blue planet would become a dusty reddish-brown. It would be a world of silence, as sound cannot travel without air. The catastrophe isn't limited to the surface and the sky. The stopping of the core's spin would have profound geological consequences. The Earth is not a perfect sphere. Its rotation causes it to bulge slightly at the equator. As the planet's rotation slowed, the equatorial bulge would begin to relax. This would be a disaster for the crust, the thin, brittle shell we live on. The crust is not flexible. As the planet's shape changed beneath it, the crust would be forced to adjust. This would trigger earthquakes on a scale that has never been seen in human history. These would not be localized earthquakes along existing fault lines. This would be a global restructuring of the entire planet's surface. This immense geological stress would also trigger unprecedented volcanic activity. The cracks in the crust would open up direct pathways for magma from the mantle to reach the surface. Giant fissures would open in the ground, flooding entire landscapes with lava. The sky, already thin and radioactive, would be choked with volcanic ash and sulfur dioxide. It would be a vision of hell. A world shaken by constant earthquakes and consumed by fire from below, all because the engine deep within had stopped its ancient rhythm. This journey has been a terrifying one, a story of a world unraveling, but it is just a thought experiment. The Earth's core is not going to stop spinning tomorrow, or any time in the next few billion years. The engine at the center of our world is stable. So why do we imagine such a catastrophe? We do it because it teaches us something incredibly important. It reveals the intricate web of connections that makes our planet a habitable world. When we look at other planets like Mars, we see a world that may have once had a magnetic field but lost it. Mars is a cold, dry, radioactive desert. It is a real-life example of what can happen when a planet's protective shield fails. We are learning how the sun's activity affects our technology, our power grids, and our satellites. We are developing systems to predict solar storms, to give us time to protect our vital infrastructure. This is science in action. We are the first species on this planet that has the ability to understand the cosmos. We can look up at the stars and comprehend the forces that shape our existence. The universe is a vast and often violent place, but in our small corner of it, a remarkable set of circumstances has allowed for the emergence of a world like ours. A world with a spinning iron heart, a protective magnetic shield, a breathable atmosphere, and liquid water. A world that is teeming with life. Understanding how it all works is the greatest adventure of all. Our journey to the core of the Earth reminds us that our planet is precious, and that the pursuit of knowledge is the best tool we have to ensure we can protect it for generations to come.